Here we are on the road to Nelson, right through there. Up there's the Peach Springs Tuff of 15.2 million years ago. The beige up there. And as it comes this way, the rocks get older. So we come to this, right here's that Peach Springs Tuff, right across the highway there. Then we come into the 15.2, then we come into 16 million year old 15.5. Blacker basalts, basaltic andesites. So we're in the black right here, in the black. But on top of the black, we get back into the rhyolite. That's all rhyolite ash and rhyolite up there, older than probably 16 million years ago. This is the upper Patsy Mine, middle Patsy Mine. If you go over, you'll turn back into this basaltic andesites, up 17, 18 million years ago, and then you'll be back into the Precambrian rocks. But today we're going to go, let's start here in the basaltic andesites and go up this wash. And it looks like we'll be going into more volcanic ash tuffs and hopefully some rhyolite flows. In the rhyolite you'll find these geodes. You can usually find them about anywhere out here. Oh, and you also find this green glassy stuff. I think this is a alteration. I don't think it's a what you call a vitrifier, a glass that was in the lava. I think these are altered porphyritic alteration of what's that green stuff? I don't think it's they're both green. I don't think it's chlorite. I think this is the other stuff, well, I can't think of it now, but I will in a second, I'm sure. I'll put the name here. So let's go up the wash and see what we see, starting with the basaltic andesites. Head up that way. It looks like either a fault or just the flow lines in rhyolite. See how it looks like it could be a fault gouge, but I doubt it. I think it's just layering flows of rhyolite. Basaltic andesites, or at least andesites. I guess, you know, the rectangular ones, if you see any, are hornblende. The splotchier, reflective ones are biotites, micas, black micas. And the background is, I don't know, some sort of darker plagioclase. Maybe calcium plagioclase. See, that would be a hornblende there. That square one. Let's go. Andesite, and I think this is an ash here. Yeah, you can see the pieces of rocks in the ash in an explosive ash. The not rounded, they're pieces of cinders. There might have been a basaltic andesite in it. Yeah, so this is an ash. Let's keep going. There's might be a dike of rhyolite coming up through the ash. I don't think that was level. It could be on its side. That might have been an ash layer that got put on its end. You see all the rocks in the ash. And then this stuff, oops, I think this is more of a rhyolite. So this might be a rhyolite dike. Yeah, that's a rhyolite dike. There's no telling. How would you tell the layers of the ash when this came up through it? I don't know. Is that a layer? I don't know. Another vertical laying, but it appears to be ash on both sides here. Here you got the white ash. Versus the tan ash. I don't know why. Andesite. So this blew up through andesite, I guess. See, all the xenoliths are dark andesites. And this lighter stuff here has bigger pieces of andesite in it. Back into white. The white just must be bleaching. They're both ash. That could be rhyolite. Hard to say. Just going by the colors. Maybe a rhyolite. And the original vein, or this ground was level. It got tilted from this up to that, about 90 degrees. And this looks like ash. A little different than on each side. This might have been a slip fault through here. You know, where the sides go this way instead of this way. A slip. That parasite is a mistletoe. We got rhyolite up top, then an ash flow with big chunks of rhyolite in it. And that's probably a rhyolite. Bigger pieces in this ash. Might be a flow, lahar. This stuff here, is that princess plume? I don't know. Or bee? I don't think it's bee bush. Might be. I don't know. Rabbit brush. Rabbit brush. rhyolite maybe. But here's one of the rocks that's fallen down here. You can see that it's I don't know what you can see. I was going to say it was a welded tuff. I think this could be a welded tuff, but it could be just rhyolite. I'm going to say that's rhyolite. Not sure. I just don't see enough ash or rocks in it to be a... Oh, look at that. Here's some more of that epidote. It's a blue epidote instead of green here. And unaltered spots, I would imagine. I'm not getting anywhere fast. All these rocks are pretty unusual. Here's epidote and rhyolite. I guess that's a rhyolite flow, but then in the flow you have bubbles that have created geodes. See the geodes? Geodes. Got all kinds of stuff. Let's go. On this side you can see I think could be a welded tuff. I'm going to call it rhyolite because I don't know no better. But say this rhyolite's unaltered. Come over here, same flow I guess. It's been in the water or something. Groundwater came through here and look at all the holes. Something is dissolving out of it. Wonder what those rocks were of. Whatever's calcite? I don't know. I don't see big rocks like that over here. Let's see what it was being dissolved out. Don't know. Here's a big piece of vitrofire. Maybe that epidote starts out as a vitrofire like this and then turns into is altered into the epidote from the vitrofires, maybe. Some chunks of rhyolite in the ash. The pinker rhyolites have the potassium, pink potassium feldspars. This is wolfberry or boxthorn, also known as boxthorn. Mormon tea, some sort of ephedra. Boxthorn. Now we're getting into the rhyolites. We'll be able to see if it's a welded tuff or a... These are like lithified tuffs, not quite welded. And that could be welded tuff. Or they're just like rock, worse than rock. Let's go. And the welded tuff, depending how all this got up and down, moved around, faulted, could be the 15.2 Peach Springs Tuff. Only welded as we get this way. We're getting closer over here to the source of the Peach Springs volcano, I guess. Not Peach Springs. Peach Springs. This is all a vitrofire being turned into epidotes. It's a vitrofire in this stage. And then when it turns green, it's a epidote. Maybe. Vitrofires. See the layering here, which means it's been rotated 90 degrees. I don't know which way. Let's go. Here's some real sandy ash. Not but that's well lithified. It's lithified, but we can see which direction the layers are going. It looks like they're going this way. See how they go in that way? So, I don't know what that tells us. This thing, well anyway, that was level at one time, going back that way. That's all I know. Sandy ash. I think this is a rhyolite flow, probably dipping down that way. But you can see the xenoliths of andesite in it. Yeah, I'd say this is a rhyolite flow as opposed to a welded ash. Guessing. Although it could be a welded ash. Rhyolite, maybe. Find a good spot, nice fresh spot. Ah, geez, I don't know. That's probably a welded ash. Looks to have. There's some gold micas there. Is that gold? Some sort of mica right there that's reflecting goldish. They all are. Some black micas. But yeah, let's call this a welded ash. Just because I don't know better. Let's go. See any animals? Any pumas? Jeez, I forgot my puma knife again. Oh boy, I'm a sitting duck. Big piece of, I would say, pyrazine. Oh yeah, pyrazine. Not pyrazine. Vitrofire. I'm thinking. Yeah, it's pretty glassy. Is that or epidote? Pretty glassy stuff. Guess we'll just keep going. Vitrofire. Vitrofires. Pile of vitrofire. Ground cherry. See all the little paper jack-o'-lanterns? Inside there's a little fruit. It might be ripe, probably green. Let's go. Well, the wash is starting to widen out. That looks like all vitrofire right there. It's the dark. I see a low spot here. Let's get up on top and go over and see if we can look at the rhyolites above the vitrofires. Let's get up there. Here we got a vitrofire with some quartz in it. Quartz, wherever there's a hole, was filled with quartz, and that looks like a fissure that got filled. And this would be rhyolite. See how they're kind of, those bubbles, gas bubbles in a rhyolite. Not in an ash. I don't think ash has gas bubbles. So that's what a rhyolite would look after it's all vitrofired and filled with quartz. Okay, let's go find some of that. Generally saying to the west, the rocks get older. But I don't know when you start going straight up and down. Is that older or younger than the ashes we've been going through? I'm thinking it's back towards the rhyolite. Oh boy, I don't know. It's above the, I think we're getting younger. but I wouldn't know. Let's get up there. Petrofire. Now rocks are starting to slide down from on top. And there's a, I'm guessing is a rhyolite flow. See how it's kind of layered? And real fine. Looks like a coarse ash. Let's go. I think we're up to the rhyolites here. Pinkish, felsic lava flows of rhyolite. Almost to the top. Almost there. $15.2 million years ago. Okay, let's sit down and figure out our next move. Nelson. Here's what these rhyolites up here look like. Not very good views. And who knows which way they were laid down. But that's about it. Fine grain rhyolitic lava. Let's find our way down. We're a little lightheaded. Let's find our way down, back around to the car. We came up that wash there. Can we go up there? I don't think so. Let's just get back to the car. Have a beer. 98 degrees out here today. Let's go. Any pumas? Wouldn't want to see a puma head pop out of one of these places. Okay. I just realized something. There's no gas bubbles on this side. So that side must have been the surface of the lava flow. And the gas didn't get out of the lava until it got to the surface. So this would be going down in the ground, and that would be just going along the surface, the side we climbed up. So we're going deeper and deeper now. Coming down the hill, now we're back into the green epidotes. That probably were a vitral fire in the rhyolites. Maybe. Now they're a green epidote. Glassy. Well, they started out glassy, yeah. Let's go.